In this video, we're going to learn about vertical displacement, and it sounds like a fancy term, but you've done it a million of times. We've done transformations and stuff like that, and graphing functions that weren't trig functions. But now we're looking at vertical displacement with trig functions or transformations, moving it up and down is what we're going to do today. So what I've done here is I've graphed three functions. A parent graph of y equals x squared. I like using this graph just because it's something you guys know. And that is the blue graph right here. That's the parabola that's out here. All right, that's the blue graph. Okay. The green graph here, I just added to the outside here. I said x squared plus 2. Notice it's not in the parentheses. We learned that if it's in the parentheses, it's going to move it left or right, opposite of the sign, right? This is outside of the parentheses, so now we know that what this is going to do, it's going to shift it up 2 units. And if I zoom in a little bit, it shifts it up 2 units from the blue one here, all right? So here's our original graph, our parent graph. This is our new graph here that was shifted up 2 units because we added 2 to the function. And then this pink graph right here says it's y equals x plus 1 squared plus 3. Well, if it's inside the parentheses, it means it's going to move the vertex left 1 and then up 3. So we went over here, we went left 1. My scale is not, it's in halves. So left 1 and then up 3. So that is my pink graph right there. That's where the vertices are now. And that's why it's shifted over to the left. So that's something that you've seen before. I'm hoping that wasn't too big of a stretch for you. But we can do the same thing with trig functions now. And so what this is saying, we already know this right here, this part right here. We already know that part. Okay, we know the a sine of kx plus c. That should look familiar. That's where our amplitude, that's where the a came from, amplitude. Our period came from 360 divided by k, or 180 divided by k if it was a tangent function. And then our phase shift came from negative c over k, right? Well, we can also move it up and down. This was moving it left and right inside the parentheses. Moving up and down is outside the parentheses. And it goes the same way as what our sign is indicating, okay? So all we do is we translate it up. So here I have one example for you. Pretty simple example. And we'll go from there, all right? So what happens now, y equals cosine x, graph y equals cosine x, and y equals cosine x plus 3, just to show you how this works. Okay, so I'm going to draw my x and y axis. And we've been through this many times, mostly with sine graphs, I guess. So cosine, so we'll walk through this, I guess. Cosine has an amplitude of 1, so it's going to be in between 1 and negative 1. It's important. Its period is 360 degrees, and we know if we divide that by 4, we get 90. So every 90 degrees, one of our important parts are going to happen, or points are going to happen. Okay, we know that the cosine of 0 is 1, so that's going to start right here, and then we know that it works its way down at every 90 degrees, just like so. Okay, so that's our regular cosine graph right there. That's one period of it. Okay, and then obviously it keeps on going in both directions forever, right? Okay, so all this is doing now is saying, okay, take these values, cosine values, and then move them up 3. All right, okay, so cosine of 0 is 1, but when we add 3 to it, it's going to be up here at 4, right? And this is 0, but when we add 3 to it, it's going to be up here at 3. We'll just call that 3. Okay, and this one's at negative 1, but we add 3 to it, it's going to be up here at 2, right? And so forth. So 0, this one's going to be 3, and this one's going to be 4, like that. So all it did, and maybe the easiest way to graph it for you, is to take your x-axis. That was a bad graph. I messed that up. But take your x-axis and move it up 3 units. So up there's 1, there's 2, there's 3. Put a little dashed line on it, indicating that you've shifted it up. And you know that cosine starts at 1 at 0, and then at 90 it's down at 0, and then at 180 it's down at -1. Well, in this case, it's going to be 2, but it's down 1 from where our new quote-unquote x-axis is. Okay, so all I did is shifted my x-axis up, and then I know it's at 0 at 270, and I know it's up 1 at 360, so that looks like a much better graph than what I had before. Okay, and so forth. So that's all vertical displacement is. Again, you can still have everything that we learned in the last section as far as shifting it left or right, but maybe the easiest thing for you to do is just make a dashed line that's your new x-axis and graph it like that. Hope that helps. See you.